right, here's the 2011 question from Taylor series that somebody requested. That's the absolute value of the fifth derivative, and you're like, how important is that? You know, I put that equation, it's in your problem here. Again, have that out with you. So we'll use that in the third or last part, I guess, part D. All right, so here it says, let f of x be sine of x squared plus cosine. So they're going to kind of, in A and B, walk us through to get to that equation, all right? So first off in A, it asks for the first four terms. It's not saying fourth degree, it says the first four terms of this Taylor series about sine. Well, we're supposed to have that memorized. So if you remember, sine is the odds. So there's the first four terms. We got four terms down. And it says, and use it to write the first four of sine of x squared. So we're going to replace every term with x squared. So I replace x with x squared. I'm going to replace x squared for that x, so I'm going to get x squared cubed, which is x to the sixth. X to the 10th. X to the 14th. All right, so that's sine of x squared. All right, that's all that A wanted us to get to that point. B says, now write out cosine. Well, we have cosine memorized. And there's the first four terms of cosine. So they asked for the first four. And they said, use that and this to come up with this. So they want this series. So it's sine of x squared plus cosine. So they want me to add these two. Okay, let's do that. So, and they gave it the name of f of x. Well, I'm adding like terms. And how many terms does it want for this here? So they just want the first four. All right. So these are both x squared. So these are like terms right here. So I have 1x squared minus a half. So that's a half plus a half x squared. All right, the next term is next to the fourth. And the last one, these guys are like or x to the sixth. So this is minus 1/6. This is minus 1 over 720. So common denominator for that would be 720. I'd have to multiply this by 120. So I actually get negative 121 over 720. That's combining those guys. Let me erase that. X to the sixth. I don't care about the other terms because I only needed the first four terms. So they can ask you to add some series, just, add up the like terms. All right, so that's the first four terms. All right. And then it says, find the value of the sixth derivative of this. Well, I don't want to take sixth derivatives of this, sixth derivative at 0. But you remember, the number in front will help you with the sixth derivative. So in front of this term, this part right here, if you remember our Taylor series, the formula is the sixth derivative of a function over 6 factorial times x to the sixth. This 6 factorial could be underneath either part. So if you remember, I kind of gave you the shortcut in class saying, hey, you take this number factorial times that. But my answer is going to be negative 121. So the 6 factorial is 720. So what this is this over 720 will cancel out. The 6 derivative over 6 factorial equals this, the 726 factorial out. So I get x to 6 is negative 121. All right. So again, to solve it, this part would equal this. The part in front of the x to 6. These two cancel each other out, is really what I'm saying. All right, let's go to part D. Again, the Lagrange was taken off the test, so they want us to show the errors, the error of our value is less than 1 over 3,000. All right. Well, what we have to do is the first neglected term. So they said let P of 4 be the Taylor. So now they want me to look at P of 4. So I'm going to erase this. All right. Using information from the graph, show that the error is less than 1 over 3,000. So they wanted me to start at 4. The reason is the way Lagrange works, it's not the next term, it's the add one term. So even though it goes 2, 4, you might be thinking 6 would be the next term, but no, Lagrange says just add 1. So 4 plus 1 would be 5. All right, so they want us to find the error, use their notation. So they said show that it's actually less that value. So what they're saying is when you plug in 1/4 into your series, show that the difference between that and the actual function is less than 1 over 3,000. Well, remember what the actual this is. I'm going to erase this 1 over 3,000 for a second. It's the maximum what the derivative could be. So what is the maximum at 1/4? Well, if this is 0, this is 1. Right here is 1/4. So if I look at the graph carefully at 1/4, it looks like it's around 38 or so. But you could cover your bases by being oversure and saying 40. You're hurting your chances of it working at 40, but if you can show it for 40, of course it works for 38. So you just do 40. Now remember, it's the maximum times the next term. Well, the next term, this was x to the 4th, would be x to the 5th over 5 factorial. And you're plugging in 1/4. All right, so we got to plug that in. You do the math, and it turns out this is 1 over 3072. Well, that's definitely less than 1 over 3,000, so therefore we have shown it. So just remember when Lagrange happens, you got to go one more term. So you're going to plug into, if this is 4, you're going to be plugging into 5. The multiplier is always the maximum the derivative could be. That's why they said, here's the absolute value of the 5th derivative, the maximum will occur, and that's why at 1/4 we say around 40. So we weren't sure if it was 38, 39, so 40 will cover our bases. We know it's definitely less than 40, and so if we show it's still less than, and we took, we went further than we could have, then that works. All right, and that's it. So that was the one requested.